right.
Being unemployed can actually boost your career.
Yo. Do we have a guest in Discord? Hello, hello. GC in the house? Oh, let me get my camera going in Discord. Aha. There we go. So, GC, what's up?
Um, yep. I just saw your Discord message and
Oh, cool. Your audio's a
and
little. Your audio's not that great, but
okay.
thanks for joining. Yeah, have you been using VizHub by any chance?
Yes, just starting. But most of the time I just use the ID to experiment with D3.
Nice, nice. Where are you from?
Michigan.
Michigan. Nice. Oh, I just took a road trip through Michigan. Beautiful,
Oh,
beautiful.
cool.
So, yeah, today I posted this event. Let me pull that up real quick. I'm still working out this live stream setup. But I posted this event today. I'm going to run a data visualization workshop in a week from today. And
Mm-hmm.
I hope to get people signed up and registered. And here are a bunch of sketches of the things I want to cover. And I'm going to be live streaming up until this day as much as I can to try to promote this event and make sure I'm well prepared for it. And it's based on this existing content here in this big playlist that I've got, constructing visualizations. And so on this live stream, what I'd like to do is make sort of an index of all these examples and make sure we have an example of each one of these things ready to go. And if we don't, maybe we can code it up in real time. So first of all, we've got scatterplot. And I'm going to use GitHub to keep track of all these things. Now, in constructing visualizations, we have, well, circles with D3 is definitely something I'll be covering. And this is just a basic setup, but it's unique because it introduces this VizHub version 3 runtime environment, which has these really crazy hot reloading features where you can like drag, you can hold Alt and drag, and the code does hot reloading. So this is probably where I'll start.
Sounds good.
So there's...
Am I the only one here?
Sorry, what?
Am I the only one here?
Yeah, you are.
Okay, cool. Oh yeah, I have a question for you.
Sure, what's your question?
Yeah, for scatter plot, right? When you attempt to label all the points in a scatter plot, sometimes the text you get overlap on. There's a lot of overlapping that will make the labels less readable.
Right.
Do you know of any package that will try
How
to
do you
space
deal
it
with
out
missing data?
correctly so that the labels are more readable?
Right. Well, that is a very serious problem. Thank you for the question. And you know, let me bring up this other example where I actually ran into this problem. So I made this map here that shows population density across the world, and it's zoomable. And it's essentially the same problem as labeling a scatter plot because I'm labeling points. And see, we've got labels for like New York and Chicago. And the way this works is it just filters by a certain threshold of population. But it doesn't work as well as I'd like it to. And so I actually had this idea for a labeling algorithm that would do something like render, well, first of all, sort, like in this case, well, in general, I think there would be some prioritization because you have to figure out what points do I want to prioritize labeling because you're not going to be able to label all the points, I don't think, unless you have like lines going off to the edge,
Yeah, agree.
which you might
I guess
have.
sometimes even when it is possible to, yeah, let's, well, maybe that can be made as a user option, whether they want to put it or put in all the labels, and sometimes it really can be in, but not always. Yeah.
Yeah, I mean, sometimes it can be too much. And I think maybe the best solution might be to label some of the points such that you can read the labels as opposed to labeling all the points, in which case you wouldn't be able to read all the labels because they would overlap or the text would be too small. I guess it depends on the specific use case. But with scatter plots, like usually with scatter plots, I want to see labels for the outliers. Let me pull up a scatter plot.
Oh, yeah, agree.
Yeah, like this example.
Actually, I looked this up internet, and I think there were a few abandoned D3 projects, yeah, D3 packages
Oh yeah.
for
I mean,
spacing the label.
the labeling problem is a very challenging one, and there are a lot of solutions for it. One of which is like you could use a force-directed layout with boxes. I know Elijah Meeks did a library for that, where,
Oh yeah, right, force. Yeah,
but that's the
force that.
case where you want to label all the points, and that could work, but that's pretty tricky. But you know, I do want to solve this challenge of rendering the labels properly. So here's what I had in mind for this example, and it might be relevant to you and your problem
Mhm,
as well, or not. I don't know. But I want to show the labels for these population centers. Like this one here, I want to know what city that is. This one here and this one here.
I,
Even
I, are you moving your mouse? I think your mouse pointer is uh, on the scatter plot.
really, well, that's strange because in my view, I see I'm showing the map on the screen. Are you not seeing the map on the screen right now?
Uh, I can only see all the samples. No, not all the, a few of the samples that you have.
Are you looking at your Discord video or the YouTube stream?
Oh, this one I joined from Discord.
Huh. Well, I wonder what's going on there. So I just switched it off. Can you see nothing now?
Yeah, now it's only your avatar.
And then now,
Oh, okay. Yeah, yeah.
what do
Right,
you
right.
see?
Yeah,
Oh.
there's some New York, Chicago,
Yeah, there must have been a glitch with
contour plot.
Discord. Discord must have had a glitch. But anyway, the idea that I had for the labeling algorithm is to first sort the cities by population, and then
Uh-huh.
for each city, render the label if it doesn't intersect with any other labels. And then the challenge is keeping track of which labels are there and which labels are not there yet. Actually, this would be a fun one to work on. Um, Label placement algorithm, because this is one of the topics I want to cover in my courses, but I do not have an actual implementation of it. So this would be a fun one to actually do right now. And so how would that look? I think in the map, this is where I think this is where it's rendering the labels. Yeah, so it's got these labels here.
Oh yeah.
But it's tricky because we want to like loop through. So this way of rendering the labels, it just sort of puts them all on the screen at once. But what we want to do instead is like render each one by one, and if it intersects with any other labels that are already there, then don't draw it. And then the question is, how do we know which labels it intersects with that are already there? And for that, I was thinking to use this rtree library called rbush, which is a spatial index. And so, assuming this can work, the only remaining problem is to measure the label when you render it. So, yeah, how do we measure text in SVG? Like, I don't know. Have you ever done that? Text length?
No.
Oh, it looks like text length is a thing. Let me just get my windows organized here. Yeah, so I guess the thing is, we need to render the text first, and
Yeah,
then
agree.
then we can measure it. What did you say there?
Yeah, agree. I actually have another similar challenge was trying to make a HTML table with the same height. So what I did, the first thing was just to render the HTML table, then use JavaScript to get the height, the maximum height.
Ah, right.
Yeah. So I think something similar should work. Yeah, I think the problem is that you can only get the height after you render it, right?
Right, that's the challenge. So maybe what we need to do is actually render all the labels first as a
Then
first
transform.
pass, and then once they're all displayed, go through and measure. And this is not optimal. Like we could, there's probably a different way to do this. Because when you load the viz, you don't want these all labels to show up and then some of them to disappear.
Oh, right.
But anyway, it's just a proof of concept, so that can work for now. So maybe the first pass of this is like render all the labels first, and then
Yeah.
go through and measure them, and apply this algorithm to filter out the ones that we want to hide, and then do a second pass of rendering the labels where we only render the ones that we want to see. Yeah, I like that. I like that a lot. So, yeah, to get started here, I'm going to change the threshold for the population labels, which is hard-coded here to be, what, 7 million? So if I just take a 0 off of that and rerun it, let's see what happens. We get a lot more labels. Yeah, this is what I would expect to see. Yeah, this is exactly right. So, I thought there was like a smoke alarm going off. So, the thing is now, we don't want to render these small ones that are overlapping with the big one, right?
Yeah.
So let's first go through and measure these labels. We've got them all here. And then I think I could do something like a for each or a each. Yeah, dot each, which is a D3 method. And I think if we use the function keyword, we can get access to this, which should be the DOM element that contains the label. And it looks like it is. It looks like this is the text elements right here.
Okay.
Okay,
For
great.
this, we can use the arrow function.
What was that?
We can use the arrow function.
We cannot. That's a great point. That's a really good thing you brought up, because that's the trickiest thing about each with D3 is that you cannot use the arrow functions, because the arrow functions use lexical this. And so now we get undefined. So when you use, the keyword this in JavaScript is super confusing. But the D3 API for .each, it passes the DOM element as this. It's almost like an argument to the function, but it's not. It's like it's done in this weird sort of a way. But if you research the fat arrow syntax, like on MDN, here it is, arrow function expressions. It says here, arrow functions don't have their own bindings to this, arguments, or super, and should not be used as methods, because methods, like on classes, have to access this. And usually this is assigned to the object that the method is called on, but not in the case of D3 each. In the case of D3 each, it's part of the API. Let's just take a quick look at that documentation. Each, where is it? Selection.each, where is it?
Is there a reason why they use this instead of using like the first argument of the function?
Sorry, I didn't catch that. Could you repeat it, please?
Oh yeah. Why why not instead of using this use the it could also pass argument to that function.
Right. I mean, if I were to go back and rewrite D3, that's what I would do. Make it an argument to the function. Because we got P and J, and I don't even know. I think this is like the datum, and then the second one is the index. But yeah, if it were up to me, I would pass the third argument as like the DOM element and not even use this. It's a strange, to me, it's a strange design decision for the API. And I wouldn't have done it that way, but I think it's just the easiest way for us to get access to all of the various DOM elements that we need to, because we need to get access to them in order to get the text length. But in terms of why it's like that, I don't know.
Okay.
It was a decision that I guess Mike Bostock made. And he's got his reasons, I guess. But it's super confusing to a lot of people years later. Because we can't use the fat arrow syntax, which ideally we would. Ideally we would want it. I love it. But we got to use this old school function syntax to get this to work. Just to get access to these DOM elements. So now that we've got access to all these text elements, we can, in theory, access text length Now, I don't know what this base val is. Like this example is a little complicated. But is this even it? Like, pfft. No, no, this is specifying the width. So how do I even measure the text? I know there's a way to do it.
This one sounds more like a setter than getter.
Right, this text length looks like it's a setter. Like you can specify the value of it, but that's not what we want. But I wonder, if we just log the value of it, will it give us the text length or not? No, it's this weird thing that doesn't appear. Oh, what's that? 4. Oh, they are different. Huh. Well, maybe we can use this. Let's do a little bit more research. Yeah, this is what I would have expected, like get bbox. But then that doesn't look very performant. Oh, there's get computed text length. You know, I think that sounds pretty good. Yeah, this text length thing feels a little weird to me. I don't know if it's supposed to be used in this way. But let me try get computed text length. See what that gives us. Okay. But you know what? We want the height as well. Can I, is there a thing called get computed text height? No. Well, there should be a get bbox. Because, you know, for the algorithm to work, we need to put it into this spatial index, this R bush. And for that, we need to know the actual bounding box, right? So maybe what we need is get bbox. But that's, I don't know, it'll make a lot of new objects. Oh, look at this. What is this? Yo, what is this? It looks like I started on this problem a long time ago. Yeah, it's a to-do here in the code. Well, that's funny. Well, what do we have here? Did this work? It's kind of a heavy computation, but this appears to work. Yeah, XY width height. Okay. So now all we need to do is pass this into this R bush. And you know, I got this R bush library working in VizHub some time ago. Let me see where is that?
The reason that you say that the B box is not performant is because it's returning an object.
I think so. Yeah, I
Oh,
think, because in my mind, as soon as you create a new object in a for loop, you're going to stress the garbage collection. Because in JavaScript, you know, it's a garbage collected language, and it's not, it looks like it's not reusing an object here. It's like minting a brand new object each time you call get bbox. And so to me, that's kind of just a red flag for performance, especially if you have like tens of thousands of these. There's only 1,000-ish labels, so it shouldn't be that big of a deal. But if it scales up to like 10,000, then creating a new object for each element is probably going to be a performance hit. Just because it'll, all those objects need to be garbage collected. Yeah. So
Agree.
again, like this is a proof of concept, so I'm willing to accept that for now. But I feel like there might be a better way, a more performant way. Like with Canvas, I have this feeling that if you're drawing on Canvas instead of SVG, there might be a function you could just call to measure text, which might not create new objects. I don't know. But let me just make a to-do, like, investigate performance of this. Nice. Greetings from Chile. Hello, hello. For anyone that's just joined the stream, you can access the VizHub Discord and join the audio chat if you like. So, we're trying to fix this label placement problem, which is a huge problem in this area, in China. Right, I was finding the example that uses our bush. And I believe it was one of these. Yeah, our bush. So this is an example, a proof of concept I made for contours on a map with panning and zooming. But it uses our bush internally. I'm just going to leverage the configuration of this and copy it over here to our package.json. So I could say, all right, now we are also using our bush. And I'm going to add that as a dependency. And now we should be able to import from our bush. Like this. So I guess I'll add this into map.js. And then I'll just console log it to see if the import worked. But before that, let me comment out the other console log because it's kind of a heavy output there. So if I run this, we get undefined. Oh, I might need to reload the page. Yeah, VizHub doesn't yet do the dynamic adding of dependencies. But if you refresh the page, it should be there. And there it is. There's our bush. Excellent, excellent. So how do we run it? How do we use our bush? Let me just search in this other example how it's instantiated. We create a new tree, our bush. And I'll do that down here. So, and then how do we add the bounding boxes? We call tree.load items. Huh. Tree.load items. I'm just going to pull in all this code. So we can call tree.load items on an array of objects that have these properties: min x, min y, max x, max y, and I think feature was something custom. And so let's just change this around to compute this from our bounding boxes. We could say bounding boxes.map bounding box, and then min x is going to be bounding box dot I don't know. I don't remember. Let me console.log one of these bounding boxes again, just to see what it is, what properties it has. Okay, it's got x, y, width, and height. Great. So I'll just copy that as a reference over here. And then we can go back to computing our items. So min x is bounding box.x. Min y is bounding box.y. And then max x is, well, we're going to have to compute this as bounding box.x plus bounding box.width. Pretty sure. And then for the last one, let me give AI a shot. There we go. Okay. Now, okay, let me take a step back here. This is how you index all of the things at once, but that's not actually what we want to do, right? Because the algorithm I had in mind was for each city sorted by population descending, add that label to the R tree. Definitely the first one we can render. But then for each subsequent one, we want to first, before adding it to the R tree, we want to query the R tree and say, yo, does this label that we're about to add collide with any of the existing labels that are already there? If not, then we go ahead and add it, and we keep track of that so we can render it. But if it does, then we don't want to render that label, and we don't want to index it into our spatial index either. So I don't think this tree load items is the right thing. We want to load each item individually. Let me just see the documentation for Arbush to see if there's a method where we can just add a single entry at a time. Okay, tree.insert item. Yeah. And what did we have? We had tree.load items. So let me rethink this a little bit. And we don't even need to map. We don't even need to map over it necessarily. So let me just do this sort of from first principles here. All right, let's get into focus mode. Make the text a little bigger. So here's what I want to do. For const bounding box of bounding boxes. All right, simple, old school for loop. And then we're going to want to keep track of which labels to render. So I'll maybe make a new thing called labels to render. But you know what? We sort of, when we just get the bounding box, we lose the information. So I think I want to move this call to get bbox into this loop and then iterate over the nodes. And so I'll say const label text nodes. is selection.selectAllText.nodes, and then that's what we iterate over. And then we can say bbox is node.getBbox. However, you know, I think we might need to do the each, the for each, the dot selection dot each, because what I want to do, I guess, is isolate the these D's, these data rows, and have an array of the things that we should render labels for when we're done with all this. So maybe this coming back full circle is what we need. Dot each. That way we can get access to D and also get access to this dot get bbox. Right? But let me sort of separate this from the rendering. So this is labels. Let me assign this to something. Then we want to call labels.each. This will get us access to the datum and also the bounding box. But before we do all that, we want to set up these things, the tree and the labels to render. Now, filtered cities. Let me call this actually cities to render, just so it's sort of in line with the existing code there. All right. That's a lot of figuring out how to start. But then we're going to want the bounding box as, I'll call it bbox. It'll be this.bbox. So just as a sanity check, I'm going to run this and I'm going to add some console.logs. I just want to make sure, like, are we getting the datum and are we getting the bounding box? We need both of those. Those are our ingredients. So I'll console log bbox and D and run it. Let's see what we get. All right, we got all these objects where the bbox is there and the datum is there. Okay, great. Great. And so now the overall structure is going to be if should render this city or this label, which we don't have. That's what we need to figure out. But if we should render it, then we want to add D to cities.render. So cities.render, cities.render.push D. Right? So this is coming together. Now all we have to do is figure out if we should render this city. And for that, we need to use our spatial index tree. And so it should render this label if the query to the R tree returns some value, or no, if it does not return any value, that conflicts. So let me take a step back and look at the documentation for RBush, because what we want to do is query this tree. How do we, okay, search, tree.search, tree.search. This one will return an array of data items that the given bounding box intersects. This intersection is what we're after with the labels, right? Because if the label box intersects, we don't want to draw it. We don't want to draw it at all. So let me copy this example.
But can we also consider changing this position?
Yeah, we could.
Yeah.
Yeah.
This one, maybe RBush doesn't do that.
Right. That's a whole other class of solutions for labeling. Yep. So yeah, if you have like a scatter plot with where the density doesn't go too high, then you could do something like render all the labels all the time and then just put them through like a force-directed layout just to repel them away from each other. But that's not the approach I'm going to use here. Um, because for my example with the cities, I just want to decide which labels not to show, and while retaining a readable map. But yes, that is a whole other direction you could go, is moving the labels around so that they don't intersect. But maybe the ultimate label placement solution would be some kind of a hybrid where we do this to filter out the densest areas, like to not show certain labels where the labels would be super dense, and then as a second pass, push them apart or something like that. But anyway, what I'm going to do is tree.search. And again, we need that min, this thing here, this mapping from the bounding box to the data structure expected by our bush. And so I'll call this something like search rect, or rect for our bush. I don't know what to say. And I do like the longer name bounding box, actually. And so now we've got our search rect, and we should be able to pass the search rect into tree.search and get some result. And then we should render this label if there are no results, meaning if there are no intersecting rectangles. So I think we can do result.length is 0. And so this should run, but it will still render all the labels because we're not actually adding anything to the spatial index. So let's do that. And then we may actually solve this problem and get it to totally run. So if we should render this label, then we push it to cities to render, and then we also index it in the R tree. And that was what? Tree dot insert item. And you know, just for consistency with the docs, and I'll add a link to the docs here in the code. They call it item, so I think I will also call it item right here. So we search for that item. If it doesn't overlap, then we want to add that item to the tree. And what was that? Tree.insert item. So now it should work. But how do we know that would work? I'm going to log cities to render.length. And I'm also going to log filtered cities.length. And these should be, you know, if it worked, these should be different numbers. And the cities to render should be a lot lower than filtered cities. So let's run it and see. All right, it ran. And they're different numbers. Yo, look at that.
Great.
They're different.
Yeah.
Okay.
Almost.
Yeah, almost half. Look at that. That's amazing. So let me now add some logic that will go back and remove the labels that are not in cities to render. Now we already have a D3 selection. Well, actually, what did we do here? There's a group element that's the parent. And then in that group element, we're selecting all text. So actually what I think might be the easiest way to do it here would be, well, one way would be to do this same kind of a thing, like dot select all text, and then dot data cities to render. But we already do have a D3 selection. So I wonder if we could just go through and mutate that selection somehow and like delete, I don't know, D3 selection. I think there was something like filter. Selection.filter. I don't know. Then the filter would be like for each label, if it's in this cities to render, then render it. So I think what I'll do is, yeah, I think I'll do the first idea, which is just redo this data join. Yeah. And to do that, we need to get access to this group element that's the parent. So I think I'll make a new variable. I'll call it labels G. And that will be selection.selectAllG.labels and all these attributes. And then after that is set up, we're going to call select all on that. And then, after all this is said and done, we want to update the text elements so that they only contain cities to render. So I think we can just do labels g.selectAllText.data cities to render .join text. Would that work? Would that remove the old ones? Yes. Oh my gosh. It seems to have worked. Let me take a look. Close look. No, that's, I mean, we still get all these overlapping ones. You know what? Why did it seem to work though? Like, if we look at the US, yeah, it didn't work. It didn't work at all. It totally didn't work. But if I don't have that code, do we have more labels? Yeah, we still have more labels. Okay, so this is all the labels. And if we do this, which updates the set of text elements to only be cities to render, what happens? It removes a bunch of labels. but it looks like not the right ones.
Oh, I think the data there's an optional argument called ID, right? Maybe if ID all the data, then
Right. Yeah, that's a great idea. Let me see what I could use as the ID. That's probably it. So if I log one of these, let's see, what can I use as the ID? City. It's got a name. City. All right. So let's use the key function as d.city over here. And also in the previous one too. When we render all of them, let's set up the key function like that. Yo, I think that's it. Look at these labels.
awesome.
Wow. Well, let me do the real moment of truth is when I look at China. Let me take a closer look here. So if I zoom into China, oh wow, I think it worked. Look at these labels. Wow. Well, there is an
There's still some
overlap.
overlap.
There's still an overlap. Why is there still an overlap? Well, it's much better. It's much better. But yeah, I'm disappointed that there is overlap. There should not be. Well, India looks pretty good. Now we can see Nagpur. Nice. Well, why are there still overlaps? If we look at China, there's all this very dense region still has overlaps. Why would
Did
that
you do
be?
some transformation after you get the B box?
Um, well, it is related to maybe the pan and the zoom. And right now it's doing this on each render. But after we get the B box, I didn't do any transformation. I mean, this right here is the code where we figure out the B box. I wonder if there might be something wrong with this calculation. Let me just read it in detail. Like if there's a swapped x and y. So min x is bounding box dot y, min y is bounding box dot y, max x is bounding box.x plus the width. And
Do we
then
have to
max,
swap the y?
what's that?
Do we have to swap the y? Because the y in SVG is top is 0, bottom is positive number.
Yeah, that's a good idea. That's a good point. Maybe. Yeah, y is always confusing to think about because it's inverted.
It's not matched.
Yeah. Um, do you have an idea for how to swap it?
No.
Because we can do a collaboration session. Actually, it would be cool because now we're in this setup. So I'm going to drop in the Discord the link to this, and I set it up so anyone can edit. So feel free to edit the code with me. It might be really fun.
Okay.
But yeah, maybe there's something wrong. So bounding box dot y just conceptually should be the top. You know what? Maybe we could just render rectangles on top of the text and see if it lines up.
Cool.
Yeah, just as a test. Measured, I'll call it like measured rects. Or actually items. Because we're calling this one item. So items dot push item. And then just to see what's going on, label g.select all rect dot data items. See if the AI can figure out what to do next. Yeah, that looks about right.
Okay.
Let me pull down the stroke width. Like 0.1. Oh, this is adding for all of them, which is kind of interesting because we can see the ones that overlapped are not added. I don't know, the measurement looks correct, doesn't it? Oh, you know?
Yeah.
I don't know if the data is sorted by population. Although, I don't know, I think it might be. But, you know, in any case, that shouldn't impact the collision. Let me get a slightly different view where I will only push this item if we should render this label. So now when it runs, it should just outline the ones that are rendered. And it does. And there's what the heck is going on here? There's no outline around that text that's overlapping. I wonder if it's from like an older render. Let me just refresh this page. There might be something weird going on. So if I do a hard refresh and then zoom back in, there are some cities where the label's being rendered, but the bounding box is not. See that? So what the
Oh,
heck?
is there a clash with the IDs?
A clash with the IDs, maybe.
Yeah, same city names.
Are there multiple cities with the same name, potentially?
Yeah,
Yeah. Yeah, you know, that could be it. That could be it. Yeah, that would
and,
explain this.
and yeah, I think this is the only one.
That's a great idea. All right, well, let's give all the cities unique IDs. After we load the data, let's just assign an ID as, I don't know, a random number or maybe an auto-incrementing number. I wonder, do we get I in this function? We just assign it to the index. So if I console.log I, and this only runs on page load, so I'm going to have to do a hard refresh again. And let me see if we got those IDs. Yeah. Okay, 42,000. So there's 42,000 cities there. Now they each have a property called ID, which we know is guaranteed to be unique. So now let's go. Yeah, the great insight. Great insight. Thank you for that. Now let's go and update the ID function to be d.id. There, and there's their second place, d.id. Okay. Let's see if that worked.
Yeah.
Wow, beautiful. Beautiful. It worked. It worked.
Yeah, cool.
Wow. Wow. This is a much more readable map. So let me just go back and clean up some of this dead code here. And I don't want these rectangles anymore. So I'll just comment this out. And then I'm just going to take a look around because I want to study this map. I mean, I really wanted to do this, and thank you for this inspiration to get this done, your question. Thanks for asking the question, because I really wanted to do this so that I could just study this map and see, like, what are the population centers, you know? So on the East Coast, we got New York, Boston, Washington. And there's the answer to my earlier question. What is that big one? It's Atlanta. There we go. Atlanta, Chicago, Minneapolis, and Wisconsin. There's Milwaukee there. Wow, this almost makes Milwaukee look like a suburb of Chicago. And now that I see this, I kind of want to tweak the density. What I can do is have this off screen and then look at the map, and then I can tweak some of the values. And I'll show the code just so where we can find it. The bandwidth, there it is. So as I tweak this bandwidth, let's make it 3. Yeah, so that changes it a little bit. What if I make it 2? So this is changing the calculation. Let me tweak some of these other numbers. Oh, I broke it. I kind of want to just see Milwaukee as its own separate blob, but maybe that's not going to happen. Maybe it's not even that significant that it can do that. And the bandwidth should be changing, like how blurred it is. Let's see if I bring it way up to like 10, what do we see? Yeah, that's like too broad. Bandwidth of 3 looks pretty good. Okay, cool. So so New York is huge, Los Angeles is huge, and then we've got Chicago, Toronto, Detroit, Atlanta, and then Miami. I mean, Florida's pretty packed. Look at that. And then if we see the rest of the world, wow, Mexico City. That's like huge. It's on the same level of New York City. And then what have we got here? Guatemala City, Bogota. So we got Bogota, Lima, and then, wow, I didn't realize there was such low population density in the middle. And then Sao Paulo. And then what? Buenos Aires. How do you say it? Buenos Aires. Santiago. Whoa. And then what do we got in Africa for population centers? Johannesburg, Kinshasa, and Lagos. And there's really not that. Huh. And Khartoum. Population density is really low throughout the whole huge portion of the continent. Well, I guess that's a big desert. And then we've got what? Cairo, Istanbul, Tehran, Riyadh, Casablanca. And then in Europe, it's really centered around London and Paris. And then there's Istanbul, Moscow. And yeah, this really helps with this part of the world over here. The India map is looking great. We got Delhi, Mumbai, Kolkata, Bangalore, Hyderabad. Nagpur is actually tiny in comparison. See, I used to live near Nagpur, and I thought it was a big city at 2 million roughly, but it's tiny compared to these other big cities. And then China. This is what made me want to do this algorithm in the first place, because this area is so dense. So dense. It's insanely dense. Looks like there's some weird...
Guangzhou.
What was that?
Oh yeah, I think that one of the contour is covering up the labels.
Yeah. Isn't that funny? Huh. Well, it's probably because I was messing around with the settings. I think it's
In
just due to the...
SVG, do we have some?
What's that?
In SVG, do we have something like a Z order?
Yes. Yeah, in SVG, the Z ordering is determined by the ordering of the elements in the DOM. And the way that this code is structured, it just puts everything on the top level selection, which could be a group element or an SVG element. And to solve this problem, we would probably want to set up group elements as like layers, just for the z-index layering. Because right now it just does this. Well, this is the map stuff. That's not a problem. The problem is the contours. It just does this selection on paths directly on the parent selection. And so what could happen is if a contour is added as I'm tweaking the settings, this join will actually add it on top of the labels. And so one way to solve this is to introduce a parent group element for all the contours. That way we can add and remove the contours within that group element, but because it's inside of a group element and that group element comes before the text labels in the DOM, then we wouldn't have this problem of the contours coming on top of the text. Yeah, something like this. See, we're already doing it for the labels, where there's a parent group element, and this was so that I could set all the text properties once and have it get inherited. But let's solve that problem. I mean, that shouldn't be happening. Here it is. I'm going to paste that and say g.contours. And this will be contours g. And so I'll just drop a little comment like this g element is to control z, I'll say z index. It's not, z index is kind of a loaded term. Z index from CSS does not work in SVG. So I don't want to call it z index. I'll just control it the z ordering. And then instead of putting all these paths on the selection, we could just put it on contours G. And you know, this actually allows us to simplify this logic here because the whole point of this class is to differentiate it from other paths that could be on the same, in the same parent element. So we can actually get rid of that contour path because the only paths that are ever going to be inside of this group element are these contour paths. Okay, so now if I run this, it should work. I'll have to do a hard refresh because this won't work with the hot reloading. But if I do a hard refresh, I should now be able to go in and tweak the settings of the contours and not have this problem. So let me test that by zooming into where we saw this problem. And the performance is super bad right now because it's doing all this. Yeah, it's super laggy. But it's all right. It's just a POC, just a proof of concept. So let me go in and do what I did before, which is change some of the contour settings. And that was just the bandwidth here. So if I say bandwidth is going to be 2 and run it, we get more granular contours, and then when I switch it back, like we don't get that overlapping problem anymore, because now all the contours are like contained in that group element. So yeah, to answer your question, that's one way you can do it. Introduce group elements.
So in SVG, the only way to simulate and see index is just to order the elements.
Correct. That's exactly right. Yeah, in SVG, the only way to control the ordering, the group, the Z ordering from front to back, is to control the ordering of the elements within the DOM. And we can see this actually if we inspect. I hope the inspector doesn't crash. This is a very heavy DOM structure right here. Yeah, this is super slow. But you can see here that, let me make this a little bigger, that there's a group element that contains all the text elements. And then, see, I didn't do it for the map stuff. The map stuff still has paths directly on that parent, but there's another group element. Here it is, contours. See, this group element for contours comes before the group element for the labels. And so that's why the contours, all of the contours, are behind in the Z ordering. And see, inside of this group element, if we unfold that, these are all the contour paths. You know, a fun project, a little side project, would be to redo this whole thing in Canvas, because this is sort of pushing the limits of SVG here. But yeah, basically, this works really well. And I think we solved the problem.
Oh, great. Oh, you mentioned that this is slow because of the counters or the label.
Oh, why is it slow?
Yeah.
That's a good question. I don't really know for sure.
Okay.
But it could be because of the contour rendering. Or it could be because of the label calculation. I can test that out by just not showing the contours. See, if we don't show any of the contours, and I'm live streaming too, so that kind of slows things down as well. It's, I don't know, it could be because of the map shapes too. You know, it was this example was never very fast. But this is definitely faster than it was. Now, if we don't show the labels, so yeah, it's a whole project to figure out what's making it slow. But all these paths are definitely slow. But if we don't show any labels, let me just see quickly how fast it is. It's much faster without the labels. Yeah, this is pretty smooth. So maybe it's the fact that, you know, we're measuring all the bounding boxes. Yeah, if I bring back the labels, I don't know. It's not crazy slow, but there's definitely a lag. And you know, one thing you could do for performance evaluation is use the Chrome DevTools. So if I hit record and then do some panning and then stop, this is a really nice tool that lets you see what takes the longest time. And there's this thing called layerize. I don't even know what the heck that is about. This is very strange. So there's a task, and you can zoom in here, see? Hit test, I don't know. Mouse move events, function call. I mean, where is our zoom, emit, call, set attribute? I don't know. This is a strange looking calculation. Let me do it one more time. So I'm going to move this around a bunch. So all these little deep ones should be the actual rendering. But you see there's these big ones. But it seems to be a lot of the SVG rendering. Like I think layerize is an SVG rendering thing. And then there's also this hit test thing. I wonder if we put like pointer events none, it won't try to do the hit test. Because that's like trying to figure out which thing you're hovering over. But yeah, that's kind of a strange looking profile. So yeah, I don't know. But if I were to build this out into a more performant product, probably what I would do is, well, first of all, memoize this entire label calculation, because you don't need to recompute it on each render, because the projection doesn't really change. It just scales up and down. If it were a globe or something, you'd want to redo the filtering each time. But anyway, let me put this back to the way it was. Bring back the contours. Where'd the contours go? Where'd my contours go? Oh, here it is. I set it to empty array. There it is. Okay. And that should be const. All right. Sweet. So yeah, I declare this example done. Looks great. Yeah. And you know what I want to do now? Actually is make this available as like a giant piece of art you can order and hang on your wall. The labeling was the only thing stopping me from doing that. But yeah, I'll do that some other time. To wrap this up, I'll just update the README here and say a prototype, or a proof of concept rather, for a label placement algorithm algorithm that can be used to add labels to maps and scatter plots. Sweet. Wow. I can't tell you how long this has been on my to-do list, honestly. Because I'm working on this textbook, and like label placement for maps has been definitely on my to-do list, and I've had this algorithm in my head for a while. So thanks for pulling it out of me. Thanks for joining and
Yeah.
hanging out. So amazing. So I'm going to set the custom URL and then add it to my list of things. Wow, that was epic. So, all right, now we have one of the examples, advanced example, which is label it's actually more of a label filtering
Yeah.
algorithm.
Because we didn't arrange.
Yeah. Let me change it to be label filtering algorithm prototype. Amazing. And I also want to include this one. So yeah, I'm building out the index of things that I'll be covering in my upcoming workshop. And this is definitely going to be included. Sweet.
Right. Your screen is frozen.
Oh, it is?
And maybe it's technical issue.
Yeah, this streaming seems like a lot for my computer to handle. How about that?
Yeah, see the scatter plot.
Nice.
Chop.
So yeah,
Okay.
the scatterplot example is there. So yeah, the contour maps. Yeah, that's actually one of the more advanced examples. But there's a lot in between the scatterplot and the contour map, including the globe. Definitely got to cover the globe. Yeah, I don't know. I don't know what the best way to do this is. Globe. See, that's the problem. Like, there's too many. Right, so there's this globe with panning and zooming. And you know, this would be a cool one to put the labels onto, actually. But anyway. And yeah, why not talk about this submarine cables globe too? Now, I think there are a couple of ideas that I have not actually developed examples for, like pie chart. I don't think I have a pie chart example, or at least not a new one. I mean, there's plenty of pie charts in VizHub. Oh wow, that one's cool. Wow, this one's super nice. But you know, pie charts are one of those things where the labels is tricky too. I saw someone post a job just the other day, like having a. I have a scatter plot, but the labels are crap. Sorry, a pie chart, but the labels are crap. So maybe. So I'm gonna stream. Actually, I should probably wrap it up. But anyway, this is sort of where I'm at. I'm going to develop a list of all these examples and build out new ones. So yeah, I don't think I have a pie example. Let me just real quick make a pie example. Basic pie layout. So how do we do pie layouts? Let's check out the D3 documentation for pie. Pies. All right. We have a pie generator like this. D3.py. And in my examples, I like to do the named import at the top like this. And then, of course, there's always this naming conflict. But I'm going to call it pie generator. Is an instance of pie. And then how does this work? Well, this is a nice little example. Generates a pie for a given array of data. Interesting. Well, I'll just copy this. Although it seems like too simple. Like why is it just an array of numbers? Shouldn't we have like an array of things with colors? Here it is. Value. So I'm thinking I want to have different slices with different colors. And we can even use this same stuff, but just ignore x and y. So r could be the value, and I want to use the fill. So yeah, I'm going to make a pi generator over here, and then set the value accessor to be a function that returns d dot r. Why not? It's a quantity, right? So these are different radii of our circles. And then we just pass that data into the pi generator and gives us these arcs, which is an array of objects that has start angle and end angle. So let's do that step. I'll say const arcs equals pi generator of data. And then just as a sanity check, let me log this out. Console.log arcs. And sure enough, we get this array of arcs. Sweet. Now, how do we map this up to shapes on the screen? Surely there must be an example in the docs. Ooh, look at that. Examples? All right, let's take a look at these examples in observable. Now, what is going on here? There's a group element. And then there's another group element with more paths. This is super confusing to me. What's going on here? But anyway, we just have to have a path for each. All right, I think I'm overthinking it. We just need to have a path for each element. So instead of circles, we're going to have a path, right? And then we're going to set the D attribute to be what? I think this is where we need to pull in something else from D3. Arc. What is arc? Aha, D3.arc. Ah, so there's pies and arcs, and it's a whole different section of D3. All right, let's take a look at arc. It's an arc generator. And now that I think of it, the pi is not a generator, it's a layout. Do they call it a layout or a generator? No, they call it generator. Okay, it's a pi generator. Okay, fine, whatever. We got a pi generator, and then we got an arc generator. So let's pull in arc from D3 as well. And then we'll say const arc generator is arc. And then we need to have things like inner radius, outer radius, start angle, and end angle. But I think they have defaults. We may just want to specify the outer radius. Although, let me just get something to show up, and then we can tweak it. And this arc accepts one of these things that was output by the pi generator, And I think it returns the value for the D attribute. So let me just try that out. D is going to be arc generator. We should get a pi to show up. No? What's going on? Nothing? Whoa, what happened? I lost my example. All right, let me take a look at the DOM here. We have an SVG. We do have some paths. They're just zeroed out. There's just nothing there. Oh, wait a minute. The data we pass in here needs to be arcs. Still nothing. Well, maybe we need to specify some stuff. Inner radius, outer radius, start angle, and end angle, maybe. Oh, now it's looking better. Got something. I don't know. I don't know what's wrong. Let me take a look at some of these examples. I don't know. The example is pretty confusing. Arcs, arcs. I don't know what the heck. I don't know. Might not unlock this today. Why is it so hard? All right, let's debug it. Arcs. What is the value of arcs? We got 7 objects that have all this stuff. We have an arc generator. Now, what happens if we pass one of these objects into the arc generator? Like, let's console.log arc generator of the first arc. Okay, we have this SVG D attribute thing. Perfect. But it seems to be the same for all of our arcs. Like, why are we getting... Why is it the same for our different arcs? I don't know. We got the start angle and end angle. Looks right. Huh. I don't know. I don't know. Today might not be the day where we solve pie charts. Let me see if I can find like a more reasonable example. Like, okay, pie chart. Let's see. Yeah, this is what I want to see. So we got d3.pi. Value is value. Arcs is pi of data. I think we're doing the same thing. Yeah, pi generator of data. And again, like we got the arcs data. That looks good. Right? Zero to 2 pi angles. Okay, so the D attribute should be set to the arc generator. So I don't know what I'm doing wrong here. Anyway, bummer. I think I'll call it for today. I'll figure this out eventually.
The D attribute is the arc generator.
The D attribute is supposed to be a string. Yeah, the D attribute of SVG paths. I mean, this looks basically... it's the right kind of a thing. I think there's just something wrong with the... there's something wrong with something. I mean, like, here's an example. Like, this should show some kind of an arc. Let me just see if I can get anything to show up. Like, show me an arc. Okay, there's something. Look at that. Okay, we got something. What the heck is going on? Now, what if we pass this into our arc generator instead of the brand new one? We get it. There it is. And so what's the difference between our arcs and the thing that we're passing in? It's hard-coded. Inner radius and outer radius. We got start angle, end angle. I mean, where do we specify inner radius and outer radius? Is that on the pi generator? No, it should be on the arc, right? Or is it on the pi? Is there an option? No. There's no inner radius and outer radius on the pi. It's an option on the arc. So I wonder if I leave out outer radius, what happens?
Do you have the data?
The data, well, yeah, this one here is just appending a new one, but the data is arcs, which looks like this. We got end angle and start angle and value. Oh, fill? Is fill the issue? Oh my gosh. Does it have to be d.data.fill? Hmm. What if I just set the fill to be black? Like, I don't know. It's not showing up. And if we inspect the DOM, we are getting paths, but they're just this. Oh, are they off the screen? Is it just off the screen? Oh. Oh, I just got to move it over. Oh my god, maybe it was just off the screen. This is ridiculous. Okay, but they're all in the same spot. And end angle is supposed to be 2 pi, which I think is the default. Okay, there it is. Oh my god. That was ridiculous. Okay, well, there it is. That was way too hard. That was way harder than it was supposed to be. Let me just clean it up, put it in the middle. So we got width and height. I'm just going to use width and height to put it in the middle. Let's say oh, and I think we can use all the defaults. Whoa, that's not right. Okay, inner radius is 0, outer radius is 0. Okay. Now, this transform, I want to put it in the middle, so I'm going to translate it by width over 2 and height over 2, I guess. So now it's in the middle, right? And then this outer radius, I guess I'll just hard code it. That's fine. That's fine. Okay, and I'll just comment out this dead code, and there it is. Basic Pi layout. Okay, cool. Well, thank you for joining. I think I'm going to wrap up the stream and call it a day.
Yeah.
And then I'll just add this to my list of examples for the workshop. Yeah, basic Pi layout.
Yeah, thanks.
So yeah, thanks for joining. Maybe I'll see you around in the VizHub Discord. What was your name again?
Yeah, he's from GC.
GC. Got it. All right. Thanks so much for joining. And thanks everyone for watching. I'll see you later.
Thank you. Bye.
Bye.
Yeah.